Hello ladies and gentlemen, welcome to my video. This is today's question. The solution of this question involves 4 different stages, namely integration by parts, solving limits problem using L'Hopital's rules, manipulation of trigonometry, and integration by substitutions. First is integration by part implementation by DI table methods. First row is positive. We choose natural log x sine power 2x plus 1 for differentiate, and then 1 over sine square x for integrate. Of course, we can rewrite as a cosecant square x. Second row is negative. For D, numerator is differential of x multiplied sine square plus 1, which is 16 cosine x and then sine x, while the denominator is x sine square x plus 1. And then integral of cosecant square x gives us negative cotangent x. From the DI table, we obtain q equals to negative cotangent x multiply natural log of x sine square x plus 1 for x equals to 0 and pi divided by 2, plus integral 0 to pi divided by 2 cotangent x multiply 16 sine x multiply cos x and then divide by sine square x plus 1 dx. Let's focus on the part number 1, which is j. Putting x equals to pi over 2, we have j equals to negative cotangent pi over 2 multiply natural log x sine square pi over 2 plus 1, plus limit x approaching 0, the cotangent become cosine x divided by sine x and then multiply natural log x sine square x plus 1. Cotangent pi divided by 2 is 0, multiply natural log 9 still 0. For part number 2, natural log 1 divided by sine 0 is equal to 0 divided by 0. Therefore, we can use L'Hopital rules. Using product rules of differentiation, we will get the differentiate of the numerator. This is the one. And then divide by differentiate of denominator, which is divide by cosine x. So we have limits x approaching 0. For part number 1, it is negative tangent x multiply natural log x sine square x and then plus 1. For part number 2, it is 16 sine x cosine x and then divide by x sine square x plus 1. Putting x equal to 0 to the equation, we have j equals to negative 0 plus 0 divided by 1, which is, of course, 0. Now, let's have a look of the q. This is q because j equals to 0, therefore q is equals to the second parts of the original q. Let's copy the q, change the cotangent become cosine x divided by sine x, therefore numerator of the integrand become 16 cosine square x, while denominator and integration bound remain the same. So far we completed integration by parts and then evaluate the limit using L'Hopital rules. Next is to manipulate trigonometries. We know cosine square x is equals to 1 minus sine square x. Therefore, numerator becomes 16 minus 16 sine square x. Sorry that I forgot to write the 16 in front of the sine square x. I will just edit the video with the 16 in front. We can further rewrite the numerator become negative 2 and then multiply x sine square x plus 1 and then plus the constant 18. Meanwhile, no change of integration bound and denominator. From here, we can split the q become 2 parts. Same integration bound but different integrand. Part number 1 integrand is negative 2, while for part number 2 the integrand is 18 divided by 9 sine square x plus cosine square x. This is because we changed the 1 become sine square x plus cosine square x. Let's focus on the second part k. For k, we rewrite the denominator by factor out the cosine square. It becomes cosine square x and then multiply 9 tangent square x plus 1. Let's do substitution. Define u equals to 3 tangent x. Therefore, du over dx equals to 3 secant square x, or dx equals to cosine square x over 3 and then multiply du. For the new integration bound, when x equals to pi divided by 2, u equals to infinity. When x equals to 0, u equals to 0. From here we obtain k equals to 1 over 3 integral 0 to infinity 1 divided by u squared plus 1 and then du, which is equals to 1 over 3 and then multiply inverse tangent infinity minus inverse tangent 0. We know inverse tangent infinity is pi divided by 2 while inverse tangent 0 is 0, therefore k is equals to pi divided by 6. Let's have a look of the equation q again. This is equation q. We know k is equals to pi divided by 3. So we rewrite the q equals to integral 0 to pi divided by 2 negative 2 dx plus 18k, which is equals to negative 2 multiply pi divided by 2 plus 18 multiply pi divided by 6. That brings us to the conclusion of this video. The final answer of this question is equals to 2 pi. Thank you for watching this video until the end. Please continue support my channel, subscribe, give a like and share my videos in your social media. See you tomorrow for more videos. Bye bye.